I'm very sorry. I'm very sorry. I forgot actually. So you can see here Hadoop, HDFS, and Hadoop. It is consisting of two parts: HDFS and MapReduce. HDFS is for storage, and MapReduce is for processing of big data. Okay, storage of big data and processing of big data. And I told you in the previous class that yesterday's class that Hadoop, this entire Hadoop technology is developed by using Java language. Okay, so Java is a platform independent language. Platform in the sense operating system. It is OS independent. So the programs written in one language, written in one platform, they can be executed in another platform also. That is the meaning of this platform independent. Okay, now coming to this. And let us see what are the operating systems we have in the market generally, mostly used operating systems. One is Windows, and there is Macintosh, and there is Linux operating systems. Okay, Windows, Mac, and Linux operating systems. Okay, now it is this is operating systems, and what are the file systems we have in these Windows? What is the file system?
Karnakar, still we are not able to see your screen.
Not able to. I am already sharing the screen.
It's showing as the white screen.
Is the problem with everyone? Only with you? Please. Okay. Just let me restart the session. Otherwise, okay. Let me restart the session.
Okay.
I think Sunil is able to see the screen. Okay.
Let me restart then.
Okay. Is it visible to everyone now? The screen. Yeah, it is visible. Yes. Yes, fine now. Okay. Any problem for everyone? Is any problem with anyone regarding screen sharing? Just let me know so that I can continue the session.
For me, it's okay.
If anyone, if you are facing problem, just rejoin the meeting. I think that will solve the issue. Okay. Okay. Now, just listen very carefully. Now today, Hadoop, HDFS, MapReduce. HDFS stands for Hadoop Distributed File System. Just I gave you this statement. See this here. Big data. What is big data? The industry gave this definition. The industry which is having variety, velocity, and volume. Variety, structured, semi-structured, and unstructured forms of data. Three varieties of data. And velocity, the data which is getting generated at a rapid rate with too much speed. And huge amount of data is getting generated at rapid rate and different varieties of data. This, the data which is having these characteristics is called as big data. This is the definition given by the industry. Okay, and To store, our need is to store and process this big data, huge amount of data. So the very first technology to store and process big data in the sense any amount of data. Okay, till now there is no limit. They did not give any limit on this amount of data that Hadoop can store and process. So it can store any amount of data and it can process any amount of data. So in that, Hadoop is made up of mainly two components. One is HDFS, Hadoop Distributed File System, for storage purpose, storage of big data. And one more component called as MapReduce. It is for processing of big data. Okay, this is for storage and this is for processing. Okay, now next one here. So storage and processing. Now come to this. Let us now discuss something more about this HDFS. So I told you already this entire Hadoop. Okay, entire Hadoop, that is nothing but both HDFS and MapReduce. They are developed by using Java language. Okay, so I will give you a small, this is a small point. This is one of the points about the Java. One of the features of Java, that is, Java is a platform independent language. What do you mean by platform independent? That is, it can run, the Java programs can be run in any operating system. That is, the programs written in one operating system, okay, can be run on another operating system also. They are not operating system bounded. Okay, Java, the language programs of Java are not integrated with only one operating system. They are not tightly coupled with any one operating system. They are independent. Okay, if we compile a program, if we write a program in Windows and if we compile it and if we want to run it in another environment, yes, we can run it. We need not to write the program again. Whatever the program that was compiled in Windows, the same program we can run directly on Linux or Mac. That is nothing but platform independent. Similarly, the program that we have written and compiled in Linux environment, we can run it in Windows environment. So this is called as platform independent. Okay, so to make this Hadoop to be available and to be used in all these environments, Windows, Mac and Linux, that is why they have developed this Hadoop in the Java language. Because Java is platform independent, Hadoop also becomes platform independent. Java is platform independent, so Hadoop also becomes platform independent. That is the reason why Hadoop can be used with Windows, Mac as well as Linux operating systems. Okay, now coming to this. HDFS, Hadoop Distributed File System. Okay, now coming to Windows. Just for a moment, forget about this HDFS. Just we shall see this Windows, Mac, and Linux now. Coming to Windows, what is the file system name? What is the file system that is used in Windows? Can anyone guess? What is the file system that is used in Windows operating systems? Anyone? Okay, just make a guess. The file system used, these are the operating systems and these are the file systems. Okay, so Windows uses two file systems. One is FAT, another is NTFS. I think you know about this. FAT stands for File Allocation Table and NTFS stands for New Table File System. These are the two types of file systems used in Windows operating system. Okay, two types of file system used in Windows operating system. There is a file system used in Windows, how the data is stored, how the Windows stores only in Windows operating system, how the data is getting stored. The data will be stored in these file systems. These are the file systems developed and used in Windows to store the data in Windows operating systems. Remember this. Okay. Some file. What is the file? File is nothing but data, nothing but it consists of data, right? So to store all this data, what we require a system. We require a system to store the files. That is called as a file system. In Windows, this is FAT and in NTFS are used. I don't have correct idea what is the file system that is used in Mac, but in Linux, a file system called ext3 and ext4. These are the file systems used. Okay, this is the one version, this is fourth version and third version. This is the meaning of this one. But ext stands for extendable file system. It is called as extendable file system. Okay, these are the file systems: ext3, ext4, extendable file systems. Okay, you can observe very clearly when we go to Windows. When we say Windows, there you will have C drive, D drive, E drive, F drive, something like this. But when we go to Linux environment, we don't find such partitions of hard disk like C drive, D drive, E drive, F drive, like this. That's totally different. If you are using Windows and as Linux, you can understand the difference. Okay, the way the data is getting stored, the way how the data is organized in this file system, that you can find out. Okay, so every operating system has its own file system. Remember it. Okay, every operating system has its own file system. Windows has FAT and NTFS. I don't have the correct idea of what the Mac uses. I will try to know. I will know, and I will let you know in the next class maybe. And Linux uses ext3 and ext4. These are the file system names used by Linux operating systems. What is ext is extendable file system. Okay, now coming to HDFS. From HDFS, what is the file system? What type of file system is being implemented in HDFS? Whether it is FAT NTFS or whether ext3 or ext4, which type of file system is implemented in HDFS? To implement this HDFS, which is used? That is, HDFS is used ext file system, that is the file system which is same as that of Linux operating system. Okay, the file system which is same as Linux operating system, that is being used for HDFS, but its behavior is different. HDFS and Linux. Okay, Linux is an operating system. Linux is the operating system. Okay, it's a kernel, actual Linux kernel, and the HDFS is a file system. HDFS is a file system. And what is the file system used by Linux is ext3 and ext4, but simply nothing but ext and ext4 are but extendable file systems. HDFS is a file system which is whose concept is, whose nature or whose characteristics are same as that of ext3 or ext4. That is extendable file system. Whatever the file system this Linux uses, the same file system will be used by the HDFS also. That is, the characteristics of HDFS and the characteristics of extensible file system used by Linux are same, almost same, or almost same. Okay, now let me tell you this one now. HDFS, it is a file system. What type of file system? It is an extendable file system. This is an extendable file system. Okay, and this is one file system. Remember. Next, Windows and Linux. Windows uses FAT and NTFS. FAT stands for file allocation table and NTFS stands for new table file system. Linux, ext, this is extendable file system. Okay, I'm telling you that HDFS is a file system. These are also file systems. These are file system and these are also file systems. And what is the file system of HDFS? To which file system it is similar to? This HDFS is a file system similar to ext, extendable file system. It is not same as FAT or NTFS. It is similar and it is almost the same as that of ext4. Okay, whose file system? The HDFS is a file system which is same as that of Linux file system, that is ext4. That's why I told you yesterday what is required to work with to know to understand the concepts of this Hadoop and about HDFS. I told you that you should have the knowledge of Linux. Why? Because this HDFS is same as HDFS is the file system which is same as the file system of Linux operating system. Okay, just remember this. Okay, so now HDFS is based on is almost the same as ext file system which is used by Linux. But now my question here is, HDFS, and Windows, Linux, and Mac. Now, let me ask one question. Let me make one more point clear here. Now, if we want to use NTFS and FAT, we need to have an operating system, Windows. And if we want to have ext file system, we need to have Linux operating system. This is what. So an operating system is required. In that operating system, a file system will come along with that operating system. Remember that. Let me explain you in the next slide clearly here. Okay. Operating system, and file system. So an operating system comes with its own file system. Windows comes with NTFS or FAT. We can choose, when you are installing Windows, we can choose any type of file system, NTFS or FAT. That's up to you. Okay. Next, Linux. Linux flavors. There are many Linux flavors are there, like CentOS, Ubuntu, RHEL, that is Red Hat Enterprise Linux. Red Hat, like there are many versions, there are many different flavors of Linux are there. Okay, and all these use ext, extendable file system. So operating system and file system. Okay, and Mac also. I don't know exactly what the file system Mac uses. I will let you know by tomorrow. Okay. Let us say let us use some file system X. File system X. Okay, these are the file systems. Now coming to HDFS. HDFS is also a file system. It is simply a file system. It is a file system. But in order to make use of a file system, we need an OS. We need an operating system. Okay, to make use of a file system, we need an operating system. So you can find here Windows has its own file system. These file systems comes with Windows, and this file system comes with Linux. But what is the operating system that is needed to work, to make use of this HDFS? Okay, now there is HDFS can be used with Windows. HDFS can be used with Linux, and HDFS can also be used with Mac. This is the point that I want to make it clear now. Okay? HDFS is a file system which can be used in Windows, which can be used in Mac, and which can be used in Linux also. Okay, but NTFS and NTFS, these can be used only in Windows, and ext, it can be used only in Linux, and some other file system can be used only with Mac, but HDFS can be used with Windows, Linux, and Mac. Remember this point. Okay, now let's come to this. What is the language? Now you may ask a question. How you can say that HDFS can be used in Windows and with Linux and with Mac? How we can use? How is it possible to make a file system to work with different operating systems? That depends upon the language that is used for developing the file systems. Okay, we can see here this entire Windows and this NTFS or FAT, these are developed in C language. Okay, and Linux is developed using Unix, and the Mac is developed by using again Unix. Okay, the languages that are used, again Unix is also developed by using C language only. Okay, so C is not a platform independent language, it is a platform dependent language. Okay, but coming to HDFS, this HDFS is developed by using Java language. So when something is developed by using Java language, it becomes a platform independent. So as HDFS or entire Hadoop, the entire Hadoop is developed by using Java language, it can be used with any operating system. It can be used with Linux, it can be used with Mac, it can be used with Windows. So this is the reason why Hadoop can be used with any operating system. Entire Hadoop in the sense, Hadoop or the HDFS as well as MapReduce. Both can be used with any operating system. That is, simply now I can say that not only simply just the HDFS, entire Hadoop is developed in Java language. So entire Hadoop can be used in Windows, Linux, and Mac. That's it. Okay. So whether our systems are Windows or Linux or Mac, we can use Hadoop in that. Okay. Remember this very very carefully. Okay. Now, I think this point is clear to you now. But I'm telling you here, let me take one more point here. So HDFS is a file system which can be used with Windows, okay, and which can be used on Linux, and which can be used on Mac. It is a file system which can be used in one of these operating systems. Okay. Now my question is, Windows uses NTFS, just I told you, and it uses ext, extendable file system, and it is some file system X. Okay. Now HDFS file system is almost same as that of ext, almost same as that of ext, extensible file system. Okay, HDFS is almost same as that of extensible file system. That's why I told you in the last class that we have to be familiar with Linux environment to work with Hadoop or HDFS. This is the reason why I told you that HDFS, you must be familiar with Linux. That is, HDFS is almost same as ext file system. That is the reason I told you we must be familiar with Linux environment. Okay, even though you use on Windows or Linux or Mac, the file system used by HDFS is same as that of ext4. Okay, if it is Windows and if it is Linux and if it is some Mac, okay, so these are the operating systems. Okay, on top of these file systems, what is the file system used by Windows? It is FAT and NTFS, and the operating system used by file system used by Linux, it is ext, and file system used by Mac, some file system X. Okay. Now these HDFS, this HDFS can run on top of Windows, HDFS can run on top of ext, and HDFS can also run on top of this. This is how we can say finally about HDFS. Windows, it can run on Windows, it can run on Linux, it can run on Mac. Okay, what are the file system here? Whether it is NTFS, whether it is ext, or whether it is file system X, it can run on top of all this. Why? Because HDFS is platform independent as it is developed by using Java language. Okay, I think this is clear to you now. Any questions from this? If you have any questions, just let me know. Otherwise, I will continue. From anyone, any questions from anyone? You can put the questions in the chat, or you can ask me. I will give some 30 seconds of time. If no one responds, I will continue. Otherwise, you can ask some questions.
Kanak, are you able to hear me?
Yeah, I'm able to. Yeah, go on.
Yeah. Question is like, is the file system depends upon the operating system, or it can be, for example, if you're using Linux, is it mandatory that we need to use extendable file system? If you're using Windows, is it mandatory that we need to use the FAT or NTFS?
No.
How it will, I mean,
no, when we install,
how it will be the change?
Yeah. When we install Windows, in Windows we cannot have ext. Remember that. Windows comes with either FAT or NTFS. When you install in Windows, the file system comes along with operating system. We cannot install separately. Remember that. Okay. Operating systems have their own file systems. We cannot change those file systems. Okay, that is what.
Okay, got you. So operating system file system come along with operating system, so we cannot separate. So based on your operating system, your file system is defined.
Yes. That's right. On the above of that operating system, we use this HDFS. Okay, that on the above on the top of that file system, we use this file system.
Okay. So which is effective or efficient? Is any difference between these file systems, or how will define which operating system we need to go?
EXT would be better. That is Linux operating system would be better. Why? Because that is used in industry, in a production and real time. It is Linux is preferred rather than Windows. That is why it is preferred to go with Linux operating systems only. Mainly CentOS, CentOS or RHEL, CentOS or RHEL. Ubuntu is not preferred in production. If for learning purpose, you can use Ubuntu also. There won't be any difference. But in the production, they go with in real time they go with CentOS or RHEL, Red Hat Enterprise Linux. Okay, that is preferred. Okay, is the doubt clear?
Yeah.
Yeah. Any other questions from anyone? Okay, just remember that it is Hadoop is a framework. That's it. It is not operating system. Hadoop is not operating system. Hadoop is a framework. Hadoop is a framework. Simply, we can say it is a framework. Okay, it is not operating system. It is a framework. It is considered two components: HDFS and MapReduce. MapReduce. Okay, this Hadoop, not only just HDFS, I can say that directly Hadoop here. I will write here. Okay, Windows, Linux, and Mac. Windows, Linux, and Mac. Okay, you can use Hadoop on Windows. I can use Hadoop on Linux, and you can use Hadoop on Mac. Okay, don't get confused about this. Okay, don't get confused about this figure. Okay, and about this one, both are same. Just I skip the file system. That's it. Nothing else. Okay, both are same: Windows, Linux, and but this is the preferred one to go with. Why? Because and the Hadoop uses the file system used by Hadoop is also ext, and similarly our file system used by Linux is also ext. That is the reason it is preferred that too in industry the people go with Linux OS only, not with Windows. That is why it is preferred to go with Linux. Mainly this CentOS and RHEL is used. Okay, these are the two file operating systems used. Okay, now let me continue. No, it is a file system. HDFS is a file system. Okay, just let me tell you the differences here regarding HDFS and EXT file system and FAT or NTFS, these file systems. What is the difference between HDFS, EXT and NTFS? Okay, this is a file system of Hadoop. Okay, and this is a file system of any Linux flavor, and this is a file system of any Windows flavor. Okay, now what are the main differences? What are the main differences between HDFS and EXT and FAT and DFS? What are the difference between these file systems? Okay, now see this. HDFS, okay, it is fault tolerant. Mainly, sorry, it is a distributed file system. Is a distributed file system. The very first reason difference is a distributed file system. Whereas EXT and FAT and TFS, these are not distributed. These are standalone. These are standalone file systems. What means standalone? the file system that is confined to only a single machine, a file system that will be present in only a single machine. We cannot make that file system to be distributed to multiple machines. That is not possible. Okay, that file system that can be distributed among multiple machines, that is called as distributed file system. Okay, let me tell you that one. Let me take some machines here, nodes. Let's take 5 nodes. This is one machine, machine 1, machine 2, machine 3, machine 4, and machine 5. Let us machine 5 machines are there, 5 servers are there. Okay, now if you want to run same NTFS in all the machines, it is not possible. They are standalone file systems. But we can make a HDFS, single HDFS. I'm telling you, single HDFS. I'm telling you, single HDFS, we can make it to run in multiple machines at a time. So one copy of HDFS, okay, one copy of HDFS file system, I can make it to be distributed. I can make that file system distributed. Okay, so all these machines are working with only one file system, that is HDFS, only one instance. Only one instance. Only one instance. Suppose if I have 5 machines, now if I want to use Windows in all these machines, if I want to use NTFS or FAT, what I have to do? I should have separate Windows C installed here. I should have separate Windows installed here, separate Windows, and separate Windows. And if you want to have NTFS, 5 different machines, 5 different instances of NTFS will be there in 5 machines. I cannot make single instance of NTFS to be accessible by multiple machines. That is not possible. Okay, so we cannot make either ext or NTFS or FAT to be accessible by multiple machines. That is, only one instance of this NTFS or FAT or ext cannot be used by multiple machines. We need to have a separate instance for separate machine. But when we go with HDFS, only one instance, that is a single copy of HDFS, can be used by multiple machines. That is called as distributed. That is called as distributed file system. Remember that. This is the main and unique difference between HDFS and other file systems. What are the differences? HDFS is a distributed file system. That is, only one instance of HDFS can be used by multiple machines at a time. That is the main difference between HDFS and other file systems. Okay, this is the first difference. Okay, the first difference is it is a distributed file system. It is a distributed file system, which means that one instance, not one copy, one instance can be used by multiple machines. It's used by multiple machines. Okay, so now whatever the data, now let me tell you, let me be some more clear about this. Let me take some machines again.
Karnakar, I have one question here.
Yeah, go on.
In the cluster, can we have different operating systems, means machines?
No. It is advised to go with only one operating system, the same operating system. A cluster is supposed to have the same operating system. Why? Because the underlying, when you use Windows, let us say if you have 4 machines are there here. Let us form a 4 machine cluster, 4 node cluster. If you are using Windows here, what is the underlying operating system? File system of Windows. Let us use NTFS. Okay.
Yes.
So now let us take. So in 2 machines we are using Windows, and 2 other machines we are using Linux. Let us say ext and ext. Windows, and Linux. So on top of this we are using HDFS, right? We are using HDFS or Hadoop. HDFS. So what happens is this HDFS has to interact. This file system has to interact with this file system. Okay, see that HDFS is not created when we start the, when we start this machine. HDFS will not start automatically. It is a virtual file system. It is a virtual file system created on top of the operating system file system. Remember it. Here the operating system is NTFS. Sorry, file system is NTFS in these two machines. In these two systems, the file system is EXT. So it is a virtual file system, virtual, that is created on top of the operating system file system. It is the HDFS is a file system created on top of NTFS in these two machines, and here it is created on top of the ext4. So this HDFS has to interact with this NTFS file data storage. Okay, even though it is shown that the data is stored in HDFS, even though it is visible to us that the data is stored in HDFS, but internally it will be stored in NTFS in Windows only, in NTFS only. Remember that. Okay, it is a virtual, it is not physical, it is a virtual file system created on top of the file system of that particular operating system. So it has to interact with it. Okay, so as this we cannot have two different, I told you just now that only single instance, only one instance of HDFS will be used to create a cluster. To create a cluster, we use only one instance of this HDFS. So an instance cannot have multiple flavors of its interacting file system. It's HDFS. Here it cannot interact with NTFS. It cannot interact. It can interact with HDFS, but at the same time, again the same instance cannot interact with ext4. So one instance of HDFS is allowed to interact with, or to talk with, or to communicate with only another single what you call as flavor of this file system. It is not recommended. It is not advised to go with different flavors of this operating systems. Okay, it is always suggested to go with only one of same operating system. Okay, why? Because we are using only one instance of HDFS. If we are using different instance of HDFS, there's no problem, but we are using a distributed file system which is only one instance. That is the reason it is recommended to go with only single operator, that is same operating system in all the machines. Is it clear, sir?
Yeah, but HDFS, you told na, that file system, it will use the ext, and NTFS will use the...
No. HDFS will not use ext. I'm telling you, is HDFS, how does HDFS look like? How does HDFS look like? HDFS looks like ext, I'm telling you. Okay?
Yeah, but...
Yeah, go on.
Means if we apply any HDFS commands, how it will interact with the Windows operating system?
The commands will be same as Linux commands only. That is something like ext commands only. It interacts with Linux commands only. I'm telling you. Why? Because it is same as that of ext, right? I told you that HDFS is same as that of ext. So ext use Linux commands. So HDFS also uses Linux commands, but it almost same as Linux commands. Okay, it interacts with whatever may the file system below it. Okay, whatever may be the file system on which HDFS is created, it interacts with commands only. It cannot interact with like event based. It can interact with commands only. Okay, in Windows they have developed some vendors something like Cloudera and Hortonworks and Mapper. These are the different vendors, or we can call them as distributions of Hadoop. They have updated, they have included both command line based as well as event based also. To copy a file, to delete a file, to create a directory, generally we do in a Linux environment by using commands, or by using event driven also, by simply by right click on the mouse, then we can create a folder, we can create a file, and similar we can create a directory and file, or we do some operations through command line also. Both are possible. Okay, so we can use HDFS in command line as well as in event based. Okay, but most of the times it is for most of the operations it is preferred to go with what you call as command line operations only, instead of this event based operations. So this Cloudera, all these enterprises, vendors, they have developed flavors of Hadoop. I can say that this is one flavor of Hadoop. Cloudera company, they have developed one flavor of Hadoop, and Watermarks also they have developed one flavor of Hadoop. Similarly, Mapper, there are different many flavors are there. So they have included as basically it is command line based. But these flavors, they have included event based operations also. Okay, is it clear now? I'm still stuck with any doubt.
Okay.
Okay, now let me make clear one more this. Now, okay, now let me show you this. HDFS. Next, now second important difference. The first important difference is it is a distributed file system. That is, a single instance of HDFS can run on multiple machines. Okay, the same file system can be used by multiple machines. That is the meaning of the first difference, first point. Okay, the second point is, now suppose, let us say, in this machine we have installed Windows. Okay, Windows installation is complete. Okay, now when we copy some data, let us say we have copied some data through some pen drive or some CD or some DVD, something from some medium, we have copied data into Windows. Okay, so what is the file system in Windows? It is NTFS or FAT. We can use any file system. So when some data enters into Windows operating system, does the data gets replicated? Does the data gets replicated? No, the data will not get replicated. Suppose if we copy some file, let us say some file X, when we copy some data into this NTFS or Windows, okay, does this file X is going to be replicated? So duplicate copies of file X is getting created? No, only one copy of file will be maintained here. Okay, so and in case of Linux also, ext. Similarly, in Linux environment also, when we copy some data into this Linux environment, does that file gets replicated? No. So whenever we whenever we load some data into these file systems, NTFS or ext, the data will not get replicated. Only one copy of data will be there. That's it. Whatever the data that we copy, only that copy of data will be there. But when some data moves into HDFS, okay, when some data moves into HDFS, when we move some data into HDFS, or when we load some data into HDFS, the copy of data will get replicated automatically. We need not to do that replication. When we load some data into HDFS, automatically that data will get replicated. Okay, replication of data, automatic replication of data, So this is the second unique feature of the HDFS, that is, the data gets automatically replicated. How many copies you can have replication? How many copies? We ask a question, how many copies? And mainly, what is the purpose of this replication? What is the need of this replication? Why do you think a replication is needed? Yes, sir. Why do you think a replication is needed?
A fault tolerance to, if any file system corrupted, we have the backup.
Yes. What is the copy if I are using, if that is lost because of some reason, because of something, that some data is lost, we can have the backup of in another machine. We can have a backup in another machine. Generally, for backup purpose, we go with replication. The same concept is used in HDFS also. We are using multiple machines. and we are storing the data in multiple machines. If one of the machines goes down, there's still no problem. We can have the backup in another machine. Okay, so it is HDFS is fault tolerant to data loss. How it is fault tolerant to data loss? By going with replication. Okay, so by implementing this concept of replication, HDFS is fault tolerant to data loss. Okay, so now how many copies you want to replicate, how many copies duplicate copies you want to create, that's up to you. Okay, by default it will create 3 copies. By default HDFS will create 3 copies. By default in the sense, without our intervention it will create 3 copies. Okay, but we can have minimum we can have 1 copy, and maximum we can have 512 copies, that is 512 replications. Okay, so we can have minimum 1 and maximum 512 replications in HDFS. Okay, so if we have a file and if we have 4 nodes, we can have maximum of how many copies we can have? 4 copies. 4 copies of data will be there in all these machines. So if one of the machines is down, still no problem. Why? Because the data will be available in another 3 machines. Remaining 3 copies of data is available. No problem at all. Okay, even though machine is down, there will not be any, it will not show any impact on the data. Right? So this is how HDFS is fault tolerant to data loss. So in the normal file systems, in the Windows or Linux operating systems, what are the file systems they have? Those file systems do not have the automatic replication of data. That is not available. We want to do manually. If you want to do replication, that too by renaming a file. A file cannot have the same name. So, but in this case, in case of HDFS, a file can be replicated into as many number of copies as we want. So the number of copies depend on number of machines, number of nodes. Okay, that is obviously okay. In a single machine, we cannot have 10 replications. Why? If that machine goes down, all the 10 replications will be lost. Okay, so it is recommended, if we have 10 nodes, go with 10 replications. If we have 100 nodes, go with 100 replications. That means maximum, I'm telling you. Okay, if we have 100 nodes, it is not compulsory to go with 100 replications, but I'm telling you maximum you can have 100 replications. That is the reason. Okay, I think this is clear now. Any doubts in this?
Karnakar, as you said, if any system is down, we can go for the remaining systems.
Yes.
At the same time, if you copy the data to the remaining 3 systems, there may be a loss of data in the one which is not working, right? Then how can we maintain that data into this system?
Which is not working in the sense? So I'm telling you.
As you said.
Yeah. So the
there
data
may be a loss of data in
this. So let us say we have copied a file. Okay, the HDFS is present, the same copy. I'm telling you, same only one instance of HDFS is maintained in all these machines. Okay, now if this file in this machine, if some data is lost, and if this machine is down, what is going to happen? Nothing is going to happen. We will have the same copy of data in another machines. What is the problem?
No problem. That is fine. If you copy the data again, run some process that will maintain the data into these 3 systems.
No, we need not to do it. I'm telling you, we need not to do it. Okay, that will be done automatically by HDFS. I'm telling you, automatic replication of data. I'm telling you, just we need to mention how many copies replications you want. That's it. Okay, but now actually let us say 4 copies. So initially, as we have 4 nodes, we have decided to have 4 copies of 4 replications. Okay, suppose if this machine goes down, actually how many copies have to be maintained? 4 copies. But in 3 machines, how many copies can be maintained? 3 copies maximum. Then what about the remaining copy, 1 copy? That 1 copy will be shown as under replicated. Now HDFS will show a warning as under replication. Under replication in the sense, you have gave the replication as 4, but we have only 3 copies. That is the case of under replication. It gives us a warning. Then we have to get alert. So one of the machines is down. So we need to create one more replication. That means, let us suppose after some time this machine is up. After some time this machine is up. We can directly include this machine into this already running cluster. So now this, when the machine goes down, the cluster will consist of only these three nodes. And again, when you make this, when we can add this node, add this machine directed to the already running cluster. Okay, so that it will be added, and automatically the data gets balanced, the data gets replicated to this machine. We need not to do manually. Okay, when you delete a node, when you add a node, we need not to stop the cluster. The cluster will be running, but a new node can be added gracefully. It is called as graceful adding of a new node. We need to just refresh the cluster. That's, we need not to restart, just refresh the cluster. The node will be added to the cluster, and the data also will be replicated automatically into this machine also. So that will be done automatically. Okay.
Yeah, Karan,
Mhm.
if you like, we are saying like 4 systems, but we are maintaining only 3 copies.
Mm, mm,
Okay.
mm.
So in that scenario, like I'm not maintaining the 4th copy.
Yes.
So, but that is down and it has came up.
Yes.
So now the data in that machine, how it will be copied? We need to manually replicate from these
No,
3
no, no. I'm telling you,
systems.
we need not to manually replicate. The only thing is, uh, this is called as commissioning actually. Commissioning of a node. That is adding of a node to the existing cluster called as commission. When we add a new node to the already existing cluster, already running cluster, just we need to refresh HDFS. Just we need to
Okay.
refresh HDFS. That's it. So the command, that instruction that we gave is to have 4 copies, but we have only 3 copies. But actually, to have the balancing, replication perfectly, we should have one more node. So when we add one more node, the only thing we have to do is we have to refresh the cluster, refresh HDFS. Automatically this node will be added, and the data gets replicated to that machine automatically. We need not to do it
Okay.
manually. Okay.
Okay, so it is the same with, like, let's suppose I need to add 2 more machines to this cluster.
Yes.
So that automatically the data from these HDFS, it will be copied to the new machines.
So if
Correct?
if you have 4 machines, and the next case, if you are going with 2 more nodes, 2 more servers, that is totally now the cluster size will become 6, right?
Yes. Yes.
Now how many copies you are trying to maintain now? 4, same 4 or 6?
No, I'm just see, for copies is for only for the backup purpose or any failover situation, right?
Yes,
So
fail.
I maintain only 4 I'm maintaining, but I have 6 machines.
Okay. Okay, 6 machines. The same thing is here.
Uh-huh.
Actually, internally, these files will be, when we load a file, this file is divided into blocks. The file is gets divided into blocks actually. Remember this.
Okay.
A file gets divided into blocks. How many blocks? Let us say we have some 1 GB of file. Let us say, for simplicity, we can say 1 GB of file. This file will be divided into blocks. Blocks of size 128 MB by default. By default, 128 MB. Okay. Now let me tell you this one. So we have a file. Let me explain you very clearly. Next here, 4 nodes. Let us have 4 nodes. And if a file of size 10 GB, let us say file 10 GB, and this file will be divided into blocks. I'm telling you, file gets divided into blocks. Now we have 4 machines. Now if we want to have, let us say initially let us have 4 copies, 4 replications, 4 replications, a file with 4 replications. Okay. Now let me have what, 2 more. As you said, now six nodes are there and 4 replications, and the file size is 10 GB. Into how many blocks you would like to divide the file into, that depends upon the block size. Okay, 10 GB of file, 10 GB of file. Into how many blocks you want to divide it into? The same file? No. So when I'm saying that 10 GB of data, in the sense 10 GB of 10 GB and 4 replication, that doesn't mean that 10 GB will be there here and 10 GB will be there in another machine, 10 GB here and another 10 GB here. No, this is not the case. Okay, how it is going to maintain the data is the data will be divided into blocks. How it is going to divide into blocks, that depends upon the block size. Okay, now tell me, now let me tell you here. Now if we have 4 machines, only 4 machines, just let us skip these 2 machines, we shall include later. Okay, let us confine ourselves to only 4 machines, the 10 GB. Now I want to accommodate this 10 GB of data. So totally 10 GB into 4 replications, how many copies it will create? So total how many size it will become? 40 GB. Okay, 10 GB, 4 replications, it will become 40 GB. Now these 4 machines must be able to accommodate 40 GB. Okay, how they will be distributed, how the data gets distributed, see now. So 10 GB is there. How many blocks you would like to divide the data into? Okay, so 10 GB into how many parts you would like to divide? How many machines we have? 4 machines. So try to have 4 blocks. So try to have 4 blocks. So what will be the size of each block now? 2.5 GB. 2.5 GB. If the size, the file size is 10 GB and if the block size is 2.5 GB, totally it can be divided into 4 blocks. Okay, is it clear now? So file 1 I writing F is getting divided into 4 blocks, B1, B2, B3 and B4. Let me tell you like this. Okay, B1, B2, B3 and B4. So now first copy, first B1, B2, B3 and B4, they will be stored like this. B1, B2, B3, B4 will not be stored in the same machine. Okay, this is one copy. One copy. And second copy, again same data, right? Same data again, B1, B2, B3 and B4. What is going to happen now? Next second copy, B1, B2, B3 and B4. This is the second copy. Next third copy, again the third copy also contains same number of blocks. Why? Because same file, B1, B2, B3 and B4. Again B1, B2, B3 and B4. And finally fourth copy, again same 4 blocks, again B1, B2, B3 and B4. Okay, now you can see this. This is how the data gets distributed into all these machines in terms of blocks. Okay, if this machine is down, we can have the same file in remaining 3 systems. We can have 3 systems and we can have the backup like this. Okay, this is the scenario. Now let us include these 2 machines also into the cluster. Okay, what is going to happen? Let us see. Is this clear, sir? Now?
Yes.
Yes. Now let me show you the case where we have 6 machines. 1, 2, 3, 4 and 5 nodes, 6 nodes. Let us take the same file, 10 GB file. Okay. Now we have 6 machines in the cluster. Now we have 6 machines in the cluster and the file size is 10 GB. What do you think? What do you think the block size? Into how many blocks? Now you want to have the data to be distributed into 6 machines. Now we have 6 machines. Previously we had only 4 machines. Now we have 6 machines. Now our intention is to have the data distributed into 6 machines. 6 machines in the sense, let us have 6 blocks. So 10 GB, try to divide it into 6 blocks. 6 blocks. So B1, B2, B3, B4 and up to B6. And let us try to have 4 copies. We have 4 copies, that is 4 replications. 10 GB file, 6 blocks, 4 replications. So in this case, what is the size of each block? 6 by 10. Almost it will be some 1 point some What will be the same? 2
1 point.
1.4, I think, 1.5, 1.6. Okay, 1 point, almost
Yeah.
1.6, 1.7, 1.6 GB. Okay, like this. So blocks. Now B1, B2, first copy I am writing here. B3, B4, B5 and B6. Next copy, second replication, B1, B2, B3, B4, B5 and B6. And third copy,
And
B1, B2.
we are maintaining only 4 copies, no?
Yes, four copies I am writing. This is the
Then,
first copy.
then
This is the
no,
first
you are
copy.
copying in. Okay.
Okay, no, don't worry. As we have six machines, we can have maximum of how many replications? Six replications, I'm telling you.
Okay, so
Hmm.
when you are adding the nodes,
Hmm.
automatically your blocks will be increasing and your
No,
the
no,
copies.
no. That depends upon the block size. Let me tell you here. In this case, what is the block size here? 2.5 GB we have taken,
Mhm.
right? So how many blocks will be created? Only four blocks, right? Only four blocks will be created. Four blocks can be accommodated in four machines only, not six machines. Remember that. Four blocks into four machines, four different machines, not into six different machines. Okay, each block will be there when each machine. One block, you see this, B1 is present in four machines and B2 is present in four machines, B3 is present in four machines as well as B4. So one block per one machine. That depends upon the block size. Okay, in this case, in here the block size is 2.5 GB and we can have maximum four blocks only. Four blocks cannot be distributed to six blocks, six machines, only four machines. And in this case, what we have done here, if we want to make use of six machines, then we have reduced block size so that we have six blocks and the data gets distributed to six machines. Okay,
Yes. Okay.
okay, the same thing, the four copies but six blocks. Understand the difference here, don't get confused here. The blocks, the number of machines, the number of nodes, that will be defined by the number of blocks. Suppose let us say that six blocks, we have said that six blocks, let us say six blocks, and if this node is down, we have only five machines. So how many blocks are getting created? Actually six blocks. Okay, but when we go with the six blocks, here we have only five machines. So now in this scenario it will show that under replication. Why? Because the same blocks are getting deposited in the, see this one. What is the problem with under replication is, see this now, in this case let us take only five nodes.
And then here also we are maintaining 6 copies, right? Not 4 copies. If it is
No,
6 systems and the block size is like 6 blocks, then we are copying it into 6 systems. Then we are maintaining 6 copies, not 4 copies, right?
no, just let me show now here. Let me complete this. 3, 4, 5 and 6. Okay, file, six blocks. Okay, six blocks, four replications. Okay, first copy I'm writing like this: b1, b2, b3, b4, b5 and b6. Okay, this is the first copy. Second copy: b1, b2, b3, b4, b5 and b6. Third copy: one more: b1, b2, b3, b4, b5 and b6. And fourth copy will be from here: b1, b2, b3, b4, b5 and b6. How many copies of data we have in this cluster now? How many copies? This is first copy. This is one more copy, third copy and fourth copy. Only four replications, right? Four replications distributed across six machines.
Okay.
Okay, got the point here. That depends upon the number of blocks. Okay, the same scenario, let me show you. If I have 5 machines, what is going to happen? Let us see. Okay, the same scenario, we have 6 blocks and we are trying to have,
Karnak,
yeah, yeah.
then here, as you said, like 6 copies means like in each system, as you mentioned, like it is copying 4 copies, it seems.
Yes, yes, yes. Yes, 4 copies. See this. See this, sir. Question what you're asking. Total, how many blocks are there? 6 blocks, right? I think you got my. Okay. Total, how many blocks are 6 blocks? 6 blocks will make up one copy. Remember that. 6 blocks will make up one copy. You got my question right. You got my point right. 6 blocks will make up one copy. In each machine here, how many blocks are there? In each machine, how many blocks are maintained? 6 or 4? 6 blocks will make up one copy. Okay, that is the first point. So in each machine, how many blocks are there? 6 or 4?
Four,
4.
four,
Then how
four.
come it becomes one copy? It doesn't become one copy, right? 6 blocks will become one copy. I'm telling you. So in each machine, if suppose in each machine if you have 6 blocks, then it becomes total one copy. It's not the case, right? It is different case. It's we have only 4 blocks. Okay.
So whenever we access any if you want to access that file,
Hmm.
so the request will hit all these
Yes.
6 machines to
Yes.
complete that request.
Yes. 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 That's exactly. Okay.
Yeah, but in this scenario, like see, now it's not equally distributed among all the 6, right? Now if one node is down,
Hmm.
so you will not get the complete data, right?
See here, suppose let
In
me
6
down.
blocks,
Okay.
yeah.
Let me down the second machine. Okay.
Okay.
What are the blocks missing with this with the down of this machine? B1, B6, B2, and B5. Don't we have
Yeah.
B1,
Okay.
B2 same another copies of blocks in other machines or not? Do we have?
Yes, it's there.
Then it will make use of those blocks from those machines. Okay. HDFS will make
Okay.
use of blocks from those machines wherever available. Okay.
Okay. Okay.
From which machine that we don't have the control on that, HDFS will decide from which machine I have to make use of this block. It will make a decision. Okay, now see this.
Okay. So
Mm. So
yeah,
as you said,
we understand.
yeah, go on, please go on.
No, one more question is like, see, you are saying these are the different nodes. So where
Mm.
is the actual primary HDFS node is sitting on top of this? Like that is a different Linux operating system, or what is that operating system?
So actually all these blocks are maintained by a process called as name node. A process called as name node. That name node in HDFS total we have 3 different processes. One is name node, another is secondary name node, another is data node. Okay,
Yeah.
so when
Okay.
we get into the actual concept of this HDFS, we'll discuss everything again. Okay, this time just only the demo part, only overview part only. Okay, uh,
Okay.
name node, secondary name node, data node, 3 different processes will be there in HDFS. This name node, it is the process. It is responsible for maintaining the information of all these blocks. Okay,
Oh, okay.
information of all these blocks.
Okay.
So when a request is sent, that request will hit all the machines. So be all the machines. So if second machine is down, which block? Let us say, even though we have here different 4 blocks are there, and if in each machine we have different four blocks are there, and total in this cluster 6 copies are maintained. When we request for the file, how many copies will be accessed? Only one copy or 4 copies? Only one copy, right? Only one copy of data has to be accessed when we request for the file. Okay, which one copy? Any one copy that we don't have control, HDFS will decide which one copy has to be taken. So let us take this copy. Let us assume HDFS has chosen this copy to retrieve the data, to give the data to us when we are requesting for the file. Okay, during that time, let us say during that time this machine is down. So which block we are going to miss with the down of this machine? B2 we are going to miss. So can't we have B2 from another machine? Yes, we have B2 in another, here we have B2 and one more copy of B2 is also in another machine, right? So and think one more B2 is here. Total we have remaining 3 copies are the different 3 machines. So 3 machines, the remaining machines are alive. Even though it is dead, remaining machines are alive. So we can get the HDFS will get that, pull the data from the remaining machines, any one of these machines. We don't have control on which machine to retrieve the data from. The HDFS will decide which machine to get the data from. Okay. Okay. Now try to understand now very clearly. Now this will clear your doubts, most of your doubts. Okay. Same 4 copies, 6 blocks. 4 copies, 6 blocks. Okay, now here we have 5 nodes. We have 5 nodes. Let us see 4 copies. First copy B1, B2, B3, B4, B5, and we have one more block. Where this one more block has to be stored? Where this one more block has to be stored? In some system. Why? Because two same blocks cannot, suppose if we assume that B6 is stored in this machine also. What is going to happen with this? When this machine is down, how many blocks we are going to lose? 2 blocks we are going to lose. In this case, if a machine is down, how many blocks we lose? Only 1 block. But in this case, 2 blocks will be lost. Okay, we lose 2 blocks. So this kind of scenario is called as under replication. Under replicated blocks. You are saying 6 blocks, but the thing is each block must be on different machine. That defines 100% parallel, 100% distribution. Okay, but if the 2 blocks, if 2 different blocks are storing in the same machine of the same copy, I'm telling you, same copy of 2 different blocks are storing in the same machine, then that will be called as under replication. And what is the problem with that is, if this machine is down, we will lose 2 blocks. Okay, this is about only first copy. Let us take second copy. B1, B2, B3, B4, B5, and what about B6? Where B6 has to be? Let us take B6 here. Okay, next the third copy. B1, B2, B3, B4, B5, and what about B6? Where B6 has to be? Somewhere here. Okay, and similarly fourth copy. B1, B2, here also we get B3, B4, B5, and B6 somewhere here. Okay, like this. Now you can see here, when some of the, now I am requesting for a file. I'm looking for the file. So 1 copy of file has to be brought now. 1 copy of file. So which 1 copy? I would like to go with this copy. B1, B2, B3, B4, B5, and where is another block, one more block? It is in the first node. Suppose if this node is down while HDFS is fetching the data, what is going to happen? How many blocks we lose here? Actually 2 blocks, B1 as well as B6. Same copy, 2 different blocks of same copy are getting stored in same machine. So we lose 2 blocks in this case. But in this case, how many blocks we lose here? We use only 1 block. This is called as 100% distribution, and this is called as not 100% distribution. It is to some 80% distribution, like that. Okay, so this scenario will be shown to us in the form of a warning as under replicated blocks. Okay, so it is suggested to go with the number of blocks equal to number of machines to achieve 100% parallelism. Otherwise, decrease the number of blocks. So if you want to have replication, 100% replication with no under replication, so what is the suggested solution here? Try to have 5 blocks. If we have 5 blocks, no problem of under replication. You can have 5 blocks in 5 machines. A single copy of data will be maintained in 5 different machines. So no problem of under replication in this case. Okay, this is how we manage the data in HDFS. Okay, so it will be more.
Another one question.
Yeah, go on.
Yeah, so here once you have the 4 copies
Yeah.
and there's a 5 nodes,
Hmm.
and you cut down the one node, the first node, and we have the 4 nodes now.
Yes.
Okay, so when you're saying that the first copy B1 and B6 was we are losing from the first copy.
Yeah. Yes.
Okay, but we have the same B1 and B6
Hmm.
in another node.
Yes.
When we want to receive the file,
Yes.
the same B1 and B6 maybe have another node of different copy. May not be the same copy of the set, but
Yes.
has a different copy
Yes.
from the different copy.
Yes.
So still you get complete data set. You do not lose any data.
Yes.
But how this under replication problem will come?
That's what I'm telling you. See this. What do you mean by replication? Replication in the sense, do you suppose I want to have a backup? Okay, I want to have something backup. Do you save the same okay, two machines are there. There are two machines.
You got my question, right?
Yeah, I got your question. I'm explaining you. Okay, there are two machines are there. Okay, I want to load some file. I want to have a backup of this file. So do you maintain same file, same two copies in the same file, or different? No, say two copies in the same machine or different machines?
Normally we'll maintain the different. That's what called backup.
That's the thing we are doing here, right? If we have two blocks in the same node, then how it is called as backup? How it can be called as backup? Okay,
But
yeah, we can get the backup from why? Because we have more backups. We have many. Suppose let us say that if we do not have backup, let us say I'm telling you we cannot get backup. I'm not telling you that we cannot get backup, but it is under replication. I'm telling you under replication. Okay, suppose we have two machines and you have a file, you want to go with two replications. But what is the case if the file gets replicated, two copies gets replicated in the same machine? What is this situation called as? What is this situation called as? Okay, let me tell you once again with one more example.
no, this under replication
Under
is an
replication
issue or is an error.
yeah.
Is a warning.
Yes, I'm telling you that data distribution, HDFS is a distributed file system. The first thing, the data has to be distributed in such a way that each block of data must reside on different machine. Okay, it must be on different machine. That is called as perfect distribution of data. If that not happens, the HDFS gives us a warning that even though you are saying some, 6 blocks, the 6 blocks are not in 6 different machines. If the 6 blocks are not on 6 different machines, then it will throw us a warning that the data is not distributed properly. Under replication, in the sense it is not distributed properly. It will have two copies in a single machine. Also, we can have 10 copies of data, but that doesn't mean that we cannot get the backup. We can get the backup. The thing is, we will not have the under 100% distribution, not properly distributed data. Okay, so in this case here, two copies of same file are loaded into same machine. This doesn't mean that we don't have backup. We have a backup, but what is the problem here? The data is not properly taken backup. Suppose if we have the another copy in another machine, then we say that two copies are there and the distribution is also very proper. We say like this. Okay. Okay, don't worry
So
about
this is a more towards a distribution property.
Yes. It is a more about distribution. Okay.
Okay.
Based on the distribution only, it will decide. It will confirm about the replication. Okay. I think it's the time to wind up for today. I have one more session at 8 o'clock. It is already 8. Okay. Okay. If you have any questions, you can post them in the chat. I will try to clear those doubts. Okay.
Yeah, Karnakaran, I have one question actually.
Yeah. Go on. Please go on.
See, why we want to now if we have 6 nodes, we are maintaining the same data redundant in all the systems, right? So we are wasting the storage like that. Okay, so
Yes.
if you have a system of 1 terabyte of data, so you are repeating 1 terabyte into 4 nodes or 5 nodes, whatever your architecture.
Yes.
So is that really the way it will be, or what is that exactly? Why big data or Hadoop is suggesting
Yes.
to
Yes.
have the?
The thing is, Hadoop is meant to run on, and Hadoop is designed to run on commodity hardware, not on high-end systems. Okay. The memory
Okay.
is not an issue these days. Actually, memory is not an issue. Actually, it's not a big deal. Wastage of
Okay.
memory. That too, we don't maintain hundreds of replications. Actually, even though the maximum number of replications we can have is 512, nobody goes with 512. They go with 3 or maximum of 4 replications like that. That too, memory is not an issue these days. And one more point is
Okay.
Hadoop doesn't require high-end configurations. Hadoop can run on normal commodity machines also. So that won't be
Okay.
any problem. Okay. The memory will get wasted. That's for sure. But in order to get something, we need to lose something. So in order to lose
No.
something in the sense, we use commodity hardware instead of high-end systems. That's the thing.
Okay. So in general, in real time, so every company or whoever having Hadoop, they will maintain minimum 4 replications. You are saying, right?
That depends upon the application. I don't say that they go with
Okay.
hundreds of replicas. They go with some below 10 only. That's over.
Yeah, below 10.
That's
Okay.
that's almost sufficient, I think. Right.
Okay.
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 Okay. Okay. Thank you for today.
Thank you,
If
Tom.
any questions, just you can post me in the other. You can post the questions in WhatsApp group also, and I will try to answer
Sure.
those questions. Okay. Okay, let
Okay.
us wind
Thank you.
up the session for today. Thank you for the session. Okay, right.